Okay. Okay.
I need your signature for robotics.
Okay.
Here.
New folder.
Oh, we're having a game desk right now.
Yep. You got it.
That's cool. I need you to sign. Here.
Where do you need me to sign? Here?
You can do it. Okay.
Where are the meetings? Are they still Wednesdays?
Yes.
Hmm?
Wednesday at 8 p.m. It's the general meeting.
Is it? That's today then. Oh, okay. I can do that. I can come to that.
Okay. It's a general meeting.
Okay.
And the officer meeting is on Friday.
What time?
11
a.m.
a.m.
Perfect. I can make both those times. I'll be a little late to the general meeting
You
though.
want to come general meeting?
Where is it?
It's in engineer building 316 something. And this one too, I guess. Both of them are the same.
You don't
thing.
know my email address?
No.
Huh?
I have to pull it out. I'm not know it for sure. Humbert. Yeah, I was confused between Ted Humbert and Edward Humbert.
Oh, it's a nickname.
Okay.
Okay.
Thanks.
You're welcome. Okay, I think
I tried to push them to buy the $7 package for increase the website security and the productivity.
Mm-hmm.
Like current plan is like after 30 minutes without activity, the website was deleted. And they was like, no, we don't need that. I said, no, we need that.
Okay. Is this, what's going on here? Good. So laptop. Okay. Let me close this. We have everyone here today? You guys ready to start programming some games? Yeah. Okay. So, let's talk about the first game we're going to make. The first game we're going to make is really going to be the simplest of the three that I'd like to build with everybody. And it's one that's going to teach us how to use, obviously, JavaScript and how to use Phaser. So we're going to kind of learn the underlying architecture of the Phaser framework and kind of how it models the components that go into making the game. So let me get my computer to actually pop on here. On, laptop HDMI. You get here. Probably help to have the HDMI cable plugged into the console. And there we go. Perfect. Okay. So, at this stage, let's make sure that everyone, let me delete this midterm. Move to trash. Okay. So at this stage, everyone has downloaded Phaser, right? Okay, so before we start doing any kind of coding work or talking about anything, the first thing we should always do whenever we start making a new game project is to create a project folder. Because games typically can be very large. They have a number of different files associated with them. A lot of times you have to have sound files, you'll have art files, and you'll have your coding files. So we need one unified place where we manage all of our data. So let's start by creating a directory that's going to hold our data. So I'm just going to create a new folder, and you should do this as well. And we will call this, let's call this Dodger. So all of my code, all of my art is going to go into this directory. That is going to be our project directory. Okay. So let me do a quick explanation of the type of game we're going to build before we start doing anything moving forward. So Dodger, what is that going to be? Can everyone see? Oh, can't see with this. Here we go. If I draw here, can everyone see this? From the corner over there too? Yes. Okay, so in our Dodger game, it's going to be relatively simple. We're going to have a game world that allows for game objects to exist and move around it. In this particular game, we'll have a player, and then we'll have enemies. And the enemies, the player, which will be you, will be able to move around, and let's say the enemies are all going to come down in either one of two directions, either say from upward, downward, or from left to right, or however you want. Eventually, we can customize the movement, but for the base, simple version of a Dodger game, the idea is that you have some spatial area you can move in, which represents the game world. You have a player that the player controls, and you have enemies that just move. And if at any time the player and one of the enemies touch, you lose the game. Typically, these are like a high score challenge, so at any time, the longer you exist, the more points you get. Does that seem fair? That's probably the most simplified version of a Dodger game that you could have. And then you could start considering adding different features to the game. So we were talking about adding score. That's actually a feature. I don't need that feature for this game to work, right? The core principle behind the game is a game world, a player, and enemies. And then some defined behavior when the player and the enemy collide. Everything else is features. That could be high scores, that could have my enemy shooting projectiles at the enemy, that could be enemies that have different behaviors, enemies with different points. It could be a boss, it could have multiple levels, right? You can have different environmental, you can have power-ups. So all those are things that fit on top of this basic structure. And that's what makes the game more unique between variations that you have. So let's focus on building the base version of this game. But does everyone understand what we're trying to build? Cool. Okay, so with that said, let's hop into our Dodger directory here. And we're actually going to need to create a couple subdirectories that's going to define where some of our code and where some of our assets should go. So I'm going to create one folder, and we'll call it Assets. I'm going to create another folder, and I'm going to call it Scripts. And let me do this as well. Let me go into Desktop. Let me go into Dodger. And then I'm going to make a file. So if you have Windows, you probably just right-click and make file. I can't really do that with a Mac, so I always just open up a terminal to touch a document. I'm going to create an index.html file. So bam. So inside of my Dodger directory, I should now have three things. And again, this is all project hierarchy things. So we're going to be consistent with this for every game that we start building out. I have a place where all of my art assets live at. I have a place where all of my game scripts live at. And I have the index.html. I want to explain what that is in just a moment. But the first thing I'm going to do is I'm going to grab my phaser script that I downloaded the other day, and I'm going to put that in the scripts directory. That's the first script we're going to use. That's provided for us. We'll never have to read that. You can actually open that up if you wanted to. If you got the non-min version, you'll see it's like 160,000 lines of code. So it's the entire game framework in one JS file. But we're not going to interface with the calls to phaser by looking at the source code. We're going to use the API to do that. Okay. So before I start explaining anything else, let me also do this. I'm going to need some art assets. So I'm going to open up a quick window, and I'm going to go to Piskel, and everyone else should do this as well. We're going to create the dummy assets. You'll be able to customize them later, but let's create some dummy assets that we can use. So the first thing I'm going to do is I'm going to load up Piskel, and I'm going to resize my canvas. The default size is 32 by 32. I'm going to go to resize here, and I'm going to change it to 64 by 64. Tell it to resize. Okay.
Click create sprite. So like it's,
Oh yeah. If it didn't load anything, click create sprite.
resize to what?
64 by 64. So again, I hit this option. You'll see inside of the right-hand menu, I have preferences, I have resize, I click resize. So I need some dummy art assets that are going to represent the three things we said this game needs, so that I can just get it to code here. Later, you can decide what those things actually are going to be. So I'm going to want my player to be 64 pixel by 64 pixel. In the future, you don't have to use this dimension. Just so happens to be the dimension I'm using. So when you go back to refactor this game to make it your own, you don't have to stick with this dimension. But for now, let's everyone make a 64 pixel by 64 pixel. And then I'm going to select this tool here, the paint bucket. And for my placeholder art, I'm just going to make a green square. Bam. That's perfect. That's all I need to get going. So I'm going to go over here to where it says export. I'm going to click on that. I'm going to export as a PNG. So I'll go, actually, let's, before I export, let me save it. So I'm going to call this enemy. Oh no, player. So I'll save that. And then I'm going to go ahead and export that. So I'll just go ahead and make sure that your scale is at 1. I want the resolution here. One cool thing is that you can actually scale something up and down, but I want it to be at a scale 1. So now I'm going to select to download it. So let's download. Perfect. So has everyone done that?
Like, we're exporting to which one?
When I export as a PNG. So I selected this option, PNG, and then download. Okay, once I do that, I'm going to want to make an enemy. So I'm going to select red. I'm going to make this red. I'm going to tell this to, do I have the option to save as? Yep, I can change. So if I hit save, I can change the name of this to enemy now. And then tell it to save to gallery. So you'll see now the name of it is enemy. And I'm going to go to export and PNG 64 by 64. I'll tell that to download. Perfect. Got 2 art assets already made. The third and final thing I'm going to do is I need my game world, right? Because that's the third thing we said this game primitively needs to build something that's fundamentally playable. So my game world, I want to be, what is this? 640 by 480. Oh no, I don't want to export. Get into resize. Okay, I want 640 by 480. And again, you can customize this later. This is just what we'll go ahead and do for now. We'll resize that. I will take my tool here. I'm going to pick something that is like the blue color. There we go. That seems fine. And I'll color the entire thing blue. And then once I do that, I'm going to go to save. I'm going to call this, what am I going to call this? Background. Save to gallery, and now you'll see that I have a background. And then I'll go to export, and no, not scale 10, I want scale 1, 640 by 480, and then I'll just go ahead and download that. Okay, so at this time, we should have generated 3 placeholder assets very quickly that we'll use to build our game. 1 will represent our player, 1 will represent the enemies, and 1 will represent the background world. So at this time, I'm going to close Piscal. Is there any questions at this point?
I want to tell it not to be a square.
Oh,
That's my question.
Yeah, make sure that if you're having issues with it being a square, inside here, make sure it doesn't say maintain aspect ratio.
Oh, okay.
Make sure that that's unclicked. If you're having issues,
So then we go ahead and move those files into the asset.
that's exactly correct. Once you do that, and I'm going to do that now. So I'm going to close out of here. I'm done with Piscal for now. I'm going to go into my assets directory. And yeah, you knew exactly where I was going with this. I'm going to now put the assets that I need for this game. Oh, you know what? Let me get rid of this 3. And actually, I'm going to do a lowercase p. And I'm going to do lowercase e too. That way I'm kind of consistent with my naming schemes. Okay, perfect. So I have my background, my enemy, and my player. So at this stage, I have my assets, I have the one phaser script that's available to us, and I have this index.html page, file. So let me quickly just explain what the index.html file is going to be in terms of why we care, why we need that in our project structure. Because we're building not only games in this set of lessons, but we're going to also be building web applications. That's the intent, to give you guys 2 different exposures and things that are valuable to learn. So, web browsers are probably one of the most prolific applications that exist. Almost every computing device that's out there has a browser attached to it, whether it's your mobile device, and that mobile device can either be Android or iOS, whether it's a Mac, whether it's a Linux device, whether it's a Windows device, or even things like Raspberry Pis, right? Like non-traditional computing systems all support browsers. So the question is, what is a browser? What is? Oh God, really? Is that necessary? A presidential alert?
Thanks for wasting.
Oh my God. Is this gonna happen every time a Twitter announcement occurs?
You're gonna run out of battery real fast.
What did it say? I didn't get it.
It's just like we're testing the presidential alert system.
Isn't that like 4 times already?
Oh my. Okay.
I've about to see one of those. Even though it was staying until just now.
Browsers.
Yes.
What are browsers designed? So they're applications that allow you to interface with the internet, right? But have you ever asked yourself, what is it that a browser is designed to open and interface with? Do you guys know? So we're building JavaScript games, and I'm sure you hear that JavaScript is like the language of the web, right? And it is in fact the only programming language that is what runs inside of a browser. So if you want to do any front-side coding, if you want to run anything that's client-side, it has to happen in JavaScript. But the thing is, you can't open up JavaScript files directly in the browser, because browsers aren't intended to open up JS files. Browsers are designed to open up what are called HTML files. HTML is short for Hypertext Markup Language. All that means is that you have a file that's not dissimilar to like a TXT file or a docx file or something like that. It contains data. right? It's a text file. But the browser, as an application, parses an HTML file, and there's tags that can be associated with the data that's embedded in the HTML file, and it tells the browser how to render that data. So for instance, you could have a P tag is short for paragraph to say this data is supposed to represent text paragraphs. Whereas you have an H tag, like an H1 or an H2, those are representative of header tags. I'm not going to go too much into HTML because we need to know just a minimal amount to build games, but fundamentally browsers are designed to open up HTML files, and HTML files can embed data within it, not just text data, but it can associate like a JavaScript file to it, or like a style sheet, a CSS file to it that tells the browser what to import in addition to the data that it contains. So we want to think of the HTML file as essentially the interface or the hub between all of our JavaScript code and the browser itself. So whenever we want to launch our game, we have to launch it from the index.html file. That's like our launch point. And in fact, if you double click that now, you'll see that the browser associates that as the default application, and it'll actually try to open up your browser. If you just double click on that file. I'm not going to do that because I don't want my browser to launch. And there's nothing in there. Actually, I will do that just to show you. New window. Double click this. Yeah, see how I tried to open that up? But there's nothing in there. So, let's open this up in a text editor. You can't double click it because you'll notice it's going to try to launch a browser. So I need to edit this to include the JavaScript files that we plan on using. That our game is going to require. So I'm going to go to Sublime Text here. And now I have this so that I can go ahead and edit this. Okay, so let me kind of explain some of the tags. So a tag looks like this. It's an angle brackets, and then whatever the tag is designed to do goes between the angle brackets. So the first thing I want to do is I want to tag all the data that goes into this file as HTML data. So there's two types of tags that HTML looks for, that the browser will look for when it tries to parse an HTML file. The opening tag is here, and then the closing tag is here. And then everything that's supposed to be part of that tag goes in between the open and closed tags. So as a software developer, you want to think of this as like your open curly brace and your closing curly brace.
What's comments?
What's that?
For comments?
Oh, very good question. Comments are really weird in HTML. It would be just like that. So it's going to be, you're going to open your comment with the less than exclamation dash dash. It's supposed to look like an arrow that's pointing in that direction. And then you would close your comment with a dash dash greater than sign.
So for this situation, we don't have to have the whole dog type thing.
No, we're not going to. If you know HTML, so I'm doing bare bones HTML simply because I want to move past it, and the browser makes some assumptions for us. Having to define the document type and all that explicitly tells your browser what version of HTML to use to parse the document. But we're just going to assume that we're coding in the latest version. But what you're saying illustrates that a proficient web developer would explicitly state what version they're developing for. So as newer versions get released, it's backwards compatible. But I don't care about that. You guys will learn about the pitfalls of code maintenance months from now, years from now. Like, that's not going to affect us in the present day. And so I don't want to bog this down with a lot of complexities. So when your code breaks, by then I hope you know enough to be able to fix it. By the time HTML6 comes out. Okay, so the first thing we're going to do, I'm going to get rid of this comment for myself. Okay, so the first thing that I'm going to do in my HTML file is say, okay, I'm going to have HTML content that goes in between these two tags. And so every HTML document can be thought of as two different parts. The head part and the body part. So I'm going to include those two tags, and then I'll kind of define what those are supposed to be in just a moment. So we're going to have a head tag, and we're going to have a body tag. And again, for those of you who are Java developers, you can think of this as open curly brace, close curly brace for the Java component in this file, and this is like an open curly brace, open scope, closed scope for the body. Okay, so what goes into the head, what goes into the body of an HTML file? The body is supposed to be the data that actually gets displayed to the user. So like when you open up your browser on a website and it's like, this is my blog entry, all of that data goes into the body of the HTML file. That's supposed to be seen by the end user. That's the actual data of the HTML file. Now, all the cool designs, like whether it has like a blue background, whether it has a crazy font, whether there's like animations in there, if there's any scripts or styles, that data goes into the head. And when I say that data goes into the head, usually the external file that provides that support to the HTML file goes into the head. So it's like the meta information that the browser needs to be able to fully display this HTML file the way it's intended. Does that conceptually make sense between what the head is used for and the body is used for? Okay, so we want to link our HTML. And if we want to test this, if you just want to test this, you can put a message in the body, open it up, and it'll actually say a thing. But again, this isn't supposed to be a web dev thing. You're getting basic web dev at this point, so I don't want to waste too much time because we only get about 15 minutes. So we're going to add things into the head tag because what we really care about is putting our JavaScript files into the HTML so that they can become viewable inside of the browser. Because again, the HTML file has to be the middle point between our JS files and the browser. So what are going to be the JS files? And JS files, if you haven't caught on yet, is the file extension for a JavaScript file. So I'm going to want to attach a script. So there's a script tag. And I know I have at least one script that I definitely know I have to add at this point. Do you know what it is? Phaser, because that's the actual library that we're using to build this game. So in the head, in this opening tag of script, I'm going to have to assign an attribute. So a script has to have a source, and the source for us is, well, where are we keeping, let's consider this. Where am I keeping my phaser script? Where's the phaser script located at? It's inside of scripts, isn't it? So, and where is my index.html? It's inside the parent directory of scripts. So I can just use I could say, okay, inside of this directory is the scripts directory. Inside of the scripts directory is the phaser.js file. See? So this should be similar to the same way you navigate using the command line, right? So we're just going to give the pathway to the script we want to attach. And what's going to happen here, just so you know, is that when we launch this index.html file, the first thing that gets processed is the head tags. The first head tag is a script tag. This lets the browser know that you're going to launch some kind of JavaScript code, and so it's going to go look for this script at this file path. Okay, so in addition to phaser script, we're going to need two other things, and maybe I'll mention that right now. We'll need at least two other scripts. But I question whether I want to add that. I should add it now, and then I'll explain it. So I need this script and this script. Okay. Perfect. Okay, so when I go to build out my game, Phaser is simply the framework by which it gives us a lot of pre-built methods and classes and objects for game construction. But we need to have our own JS file that represents our unique game. So we'll have to make our own JS file that is the game.js file. But in addition to that, games, we're going to use an object-oriented approach, so we're not going to just throw all of our logic into the game.js file, because that would be an awful way of managing our code base, right? And we're not trying to hack together JavaScript, right? We're trying to use principles that we're learning in software design and development. We're trying to use software architecture principles to design a clean, modular code base. So we're going to have a separate script to represent the different scenes of our game. So let me kind of explain to you how generally game architectures work so that you kind of understand what JavaScript files we're going to need to model these games. So, and this is true not only for Phaser, but this is true for most game engines out there, whether you're working in Unity or Unreal or whatever. There's a common concept on the way that game data, the base game design is organized. And so typically it's thought of as this. A game is a collection of scenes. And so the scene is like this container that can contain the game objects. And those game objects would be like the player object. And it could be like the enemy object. And it could be item objects. So let's think about this in terms of Mario, for instance. You might have a game scene that represents level 1-1. When you go to 1-2, that is a new scene. Each scene has a Mario. Each scene has a collection of Goombas. Each scene has a collection of coins. Everything you can do within the scene, the rules of the world are defined on a scene-by-scene basis. So think about this in Mario. There are some scenes where the rules are standard gravity. You run around, you can jump. But in a water scene, it has its own set of rules that are distinct from previous scenes, right? You have the ability to not necessarily fall straight down, but you could swim up and move up and down, but your speed is affected. Does everyone kind of understand? Can you visualize that at least architectural design, that conceptual design of how to break the concept of a game down into a scene-based analogy? Okay, because that's going to drive how we're going to implement things. So based off of that, we not only need a game file, but our game has to have at least one scene that's going to contain all the plays for that scene. And some of our games will have to have more than one scene. So the two files that I'm going to add, at least at this point, and we're going to add more, because eventually we're going to have to create player and enemies, and we're going to want to design those all to be their own classes, all as their separate JS files. But initially, our first thing is just to draw an empty scene. So I'm going to need to, and I haven't created these yet, but I know I'm going to create these. I'm going to create a new source that is going to go into scripts. And inside of scripts, I'm going to have let's call it a playscene.js file. And so this JavaScript file will represent the scene data for this game. And I call this play scene because maybe one of the features you're going to want to add onto your game is maybe your game should start off with a menu scene that launches the play scene. We're not going to deal with menus with this. I don't have enough time. That's something that you can learn how to do.
Shouldn't there be a dot before like at the beginning?
Oh, yes, thank you.
Okay.
I thought I had, boop. Okay. Also, can everyone see that source code? I can try to increase it some if that's better. Also, you have access here, here, and there on the source code. Okay. The next thing I'm going to have is going to be inside of scripts again. It's going to be my game.js file, so that's going to have all my game code. So these two things don't exist, So why don't we make those things so that we're not pointing to garbage? Man, my computer is super laggy right now. Wow. Okay. Open up a terminal to task my system tremendously. Any day now. Give my computer a moment. Being bogged down by a frantic. Huh. This is frustrating. Do. Does anyone remember the equivalent of Control-Alt-Delete for Macs?
Command Option Escape.
What is that?
Command Option Escape.
Command Option Escape. Okay, what is going? Oh, you gotta be kidding me. Okay, it froze. I can't, it won't do anything. This has gone inactive.
You're at the point of where I would sign.
What's that?
I would sign out at this point.
Okay, here. Okay, look, I'm starting to get some control back. Sometimes the system likes to stutter. So how much control do I have? Can I move this? Yep. Okay, I'm back. Sometimes the system just... I don't know.
Takes a break.
Yeah, it needs a break. It's frustrating when it does that. Does anyone else have that issue with their Mac?
Oh, yeah, I do.
Yeah.
Gotta use Windows.
Okay, let me go to Dodger. So has everyone else made those though? Touch game.js. Wait, where am I? I want to be inside of assets. No, scripts. Okay, so I'm going to create my game.js and I'm going to create my play scene.js. Now notice I did two things here. I do want to point this out. I have a capital for my P for play scene, but I did not capitalize the G for game. Does anyone have an initial impression as to why I would make that distinction?
Because places like two words and then you might end up using the same two words later or something.
Oh, almost. Let me ask you this. For those of you who are Java developers, what does the capital letter typically signify? Yeah, but that's a class that I can construct instances from. So in this instance, game with a lowercase g is not going to be a class I can instantiate. It's just going to be a set of instructions that are going to run. And so just looking at my source code, I know things that I can instantiate off of and things that are just scripts. So it's going to be a code convention that I'm going to live and die by in terms of JavaScript, being able to just look at something and know what it's designed to be a part of in terms of my system. Okay, so I'm going to open up game. I'm going to open up play scene. So let me hop on over to game. Every phaser game needs some initial data. Phaser needs some initial data to know how to launch the game. So this is what the game.js file is designed for. It's to do the initial configurations so that Phaser can start your game up. So the first thing I'm going to do is this. I'm going to create a variable. So we do variable declarations in JavaScript using var. I'm going to create I'll call this config because that's what it represents, the configuration of this game. And I'm going to create a new object. So notice right off the bat, one of the cool things about JavaScript versus Java is that we are not constrained by the hierarchy of our code. In Java, all of your code, all of the instructions have to be defined inside of methods, and all of your methods have to be defined inside of classes. No such constraint is true for JavaScript. Notice I can just do a free-floating variable right here inside of this file. It's completely fine. We're going to use mostly object-oriented code, but some things don't have to be object-oriented, right? You don't have to force object-orientedness on every part of your problem, just on those parts that make sense. So the first thing I'm going to do, though, inside here is create a configuration object. So notice the way that I instantiated an object is the same way I would do this in Java. I use the new keyword, and then object uses a capital O. And I'm invoking the constructor. Now this is a generic object, right? So it's not, it doesn't, I can add whatever things I want to it. So it's just a collection of data, essentially. It's designed to collect data. So I'm going to do the following thing. So what do I need inside of my configurations? So when we launch our phaser game, what do you think, phaser? I'm going to ask you, what do you think we need to launch a phaser game? What do you think phaser cares about? Exactly, the size of the window. How wide is the world, and how high is the viewport? Oh, let's not say world, let's say viewport. How wide is your viewport, the thing the player can see into to interact with your game, and how high is it? So inside of configuration, I'm going to add a new attribute. This is another cool thing about JavaScript, is that I can dynamically add attributes into objects if I wanted to. So I start with an empty object, it has nothing, and now I'm going to go ahead and, the same way that we declare or try to access a variable inside of Java, we do the same thing on a JavaScript object, and I can assign it this value. So let's say, how big do you think the width and height should be? Yeah, the same as our game level. So we'll do the width is 640, and we will do that the height is 480. Okay. Once I do that, the next thing I need it to do is it needs to know what scene is in the game. So, again, these are very particular definitions. So when I pass this configuration object to phaser, it's going to look for a width and a height attribute. It's going to look for a scene attribute inside of this configuration object to load this stuff into the library, into its framework. So I have to tell it what scenes are in this game. And right now, and notice I said plural. What does that imply? There's more than one. So what we're going to do is we're going to create a collection, or like a array, a list, actually in JavaScript, because it's more, there's more behavior attached to it than a primitive array. We're going to create an array of scenes. So we're going to create square brackets, and I'm going to put the scene that I'm going to call, we're going to call our scene the play scene. But you see, if you made a menu, you'd actually put, say for instance, menu scene, comma, play scene, and use a comma separated list for every scene that's a part of this game. And then we'll implement the play scene next, after this, so it actually exists. And then the third and final thing that every phaser game needs is going to be, what physics system are we going to use? So one of the interesting things, and so physics, we need to add physics to the game, even if our game does not have gravity. You have to understand what a physics system provides to your game. It's not only whether your objects are falling, but physics also tracks how movement works in your game and how collision works in your game. So a physics system typically will control collisions and movement. And movement is typically controlled through velocities. So that's how we want to think of movement. We don't teleport characters across the screen. We give them a velocity and push them across the screen. We'll talk more about that when we start talking about movement. But we do need a physics system. The reason why we have to define one inside a phaser is because Phaser supports one of 3 physics systems available in JavaScript. There's the default arcade physics system, and then there's impact and matter. These are external physics engines that Phaser supports. We don't know how to use matter. We don't know how to use impact. Like, we are not coming in as experts of those built-in physics systems or those external physics libraries. So we're just going to use the default physics. It's good enough for us. But understand the reason why we have to declare that is you can very easily use one of 3 frameworks for physics. So you can use an external physics library from that which is built in case you need to do something really crazy. Okay, so here I'm going to use the curly braces to define my physics. What I'm doing here is essentially creating a dictionary with a key value pair. I'm going to say the default physics for our game is going to be the arcade physics. So those are the 4 things, those are the 4 configuration things, the bare minimal amount of things every Phaser game needs in order for you to start up the game. The width of your viewport, the height of your viewport, the collections of scenes that make up your game, and what physics system you're going to use to do collision detection and movements and gravity and things like that. Is there any questions about this so far?
So this is specifically catered to like for phases.
Yeah, this is all centered on Phaser, but you know what? Every game needs to know this thing. This is how we load it inside of Phaser in particular, but no matter what game engine you are going to use, the game engine is going to have to know what is your viewport size, what is the collection of scenes that's part of the game, and how are you implementing your physics. On many game engines, though, the physics component is usually the built-in component. A lot of them is not a modular thing. They have their own solution. Now, on some game systems, you can override this functionality and define your own. You can do that with Phaser as well. Like, if we created our own physics system, we could load it in. Just like we load in our own scenes. Okay, the last thing I'm going to do is I'm going to create my game. So I'm going to do my var game is assigned a new, and inside of the Phaser framework, inside of Phaser is a game constructor, and the game constructor requires that configuration object to get passed into it. Okay, can I hop on over to the play scene?
You're using single quotes for this, and I know you can use them in JavaScript, but I remember I haven't done JavaScript in a while, but there's something you can't do with single quotes that you can do with double quotes.
So JavaScript's very interesting. It actually utilizes 3 different methods for declaring text data. First of all, JavaScript doesn't have symbols to distinguish between cars and string data. So I can either use single quotes or double quotes. I can also use double quotes, just like this. This is completely fine. I can also use the ticks. And the ticks illustrate a raw literal, so it can actually embed things like the new line character as the actual new line as opposed to doing /n. That's a feature Java's going to add in Java 12, by the way. So again, pulling inspiration from JavaScript. Okay, I'll use double quotations since that's what we're used to. Okay, if everyone's good with this, I'm going to hop on over to play scene. And I want to do placing. I actually want to just at least finish this first step before we break for the week. So here, I'm going to define a class such that I can create an instance of placing. I want to start getting the habit of defining my scenes as classes because eventually, once I build one class, I might want to extend it to build, once I build one scene, I might want to extend it so I can build a different second scene, and third scene, and fourth scene, and things like that. So I want to get in the habit of doing object-oriented JavaScript. So I create a class the same way I do in Java. I start with the keyword class. I, by convention, give my class name a capital letter. Here I'm going to call this play scene. I'm going to, now my play scene has to extend the concept of a scene that is a phaser scene, right? I want to take a phaser scene and I want to make it my own. I want to define my own things. So phaser has a generic abstract scene. So for those of you who are in 2120, you understand inheritance already. So what I want to do is I want to take the abstract phaser scene and extend my scene off of that so I can give it my own set of behaviors. So I'm going to say my play scene extends phaser.scene. And then I'm going to open and close my curly braces. And then everything that's part of my class, my placing class, is going to go inside of here. So I'm going to state.
Placing or scene? Phaser.placing?
Oh, I'm sorry, scene. Got in the habit of. Boop. Thank you. Okay. So every phaser scene needs at least 4 methods. And these 4 methods will always be called on a scene. You can have more than those methods inside your scene, but those have to be helper methods that can invoke in one of these 4 scenes. Does that make sense? So the only methods that are guaranteed to get called are the 4 methods I'm about to show you. So we're going to add those in first and foremost just to scaffold out our project. But I want to use an analogy of what these different components to this scene requires. So again, we talked about how we use the concept that a game is broken into scenes and the scene contains the game objects. I want to do a parallel to what the driving force behind that breakdown was. Has anyone seen or been in a play before? So this concept comes from plays. So has everyone at least seen a play? Okay, so a play has a couple of different states, right? You have to, so say we all wanted to put a play on together. The first thing we have to do is we have to decide what play we want to do, right? So we go through all the different possible plays. We essentially have to construct the play. That's what the constructor does, right? It instantiates the particular play that you want to do. So I'm going to do this one by one. So we know we need a constructor. Of course, you guys already know we need a constructor because you're Java programmers. Also, let me say that constructors in JavaScript, I think, are much cleaner than defining a constructor inside of Java. Java is really weird. It doesn't have a return type. It uses the same name as the class name. It's the only method that has a capital letter, right? It breaks a lot of conventions on method naming. With JavaScript, and this is true for Python as well, you just call it constructor. And that's it. Okay, so the constructor, that instantiates our play scene. That's going to set up all the attributes in our play scene. But there is the preload, the create, and the update. So these are the other, besides your constructor, you need to have these 3. These 3 methods guaranteed to get called, will get called when Phaser runs your game. Any other method you create that's going to be part of your game has to get called in either the preload, create, or update method. So now the trick for you is to know what goes in the preload method, what goes in the create method, and what goes in the update method. And this is where I want to toggle back to a play again. So let's say we're going to construct the play. We know we picked the play we want. What's the next thing you do logically as soon as you said, okay, we're going to do Hamlet? What's the next thing we would do if we actually want to put this play on?
Get the stage ready.
Well, before we can even get the stage ready, we gotta go shopping, right? You gotta go buy your costumes from the costume store. You gotta go buy your paints, and you gotta get cardboard to build the sets out, right? Before you can start building anything.
Aaron's trying to come over to class. He has a class here.
Oh, I know. That's fine. We have a little bit of time just to finish explaining this. Okay. The idea of going to the store and picking up the things you need for your play, that's what the preload method is. You can come in. I'll be done in just a few moments. You can come in. I'll be done in just a few moments.
Ted,
Uh-huh.
we need to set up for an exam in like now.
Oh. Do you guys want to move over to the next classroom? Let me just finish this little bit in the classroom over.